Hello everybody, let's take a look at the daily math challenge for the college entrance exam on December 29th. Today I have for you a challenging multiple choice question on probability and statistics, suitable for final exam preparation. You can pause the video now to read the question and get a sense of its difficulty. If you're interested in this series, feel free to give it a like and follow so you won't get lost next time. The question states, 3 people, A, B, and C, are playing a ball passing game. Each time the ball is passed, the passer is equally likely to pass the ball to either of the other two. If A passes the ball first, then after 6 passes, the probability that the ball is in B's hands. If you have a bit more experience with these kinds of questions, or if you've done some extracurricular study, you'll quickly realize that this is a classic example of what type of problem? A Markov chain problem, right? A Markov chain problem, which is also a frequent guest among our most challenging questions. It's a staple in advanced problem sets, a frequent guest. So what are the characteristics of this type of problem? The typical feature, to put it simply in plain language, is that the probability of the outcome at the nth occurrence depends only on the result of the previous occurrence, that is, the n minus first result, and not on any results before that. Those earlier things, what are they called? Their influence or correlation may not be as strong. It directly states that only the result of the n minus first occurrence affects the outcome, right? So when we're investigating the situation after the 6th pass, do we only need to know the possible outcomes of the 5th pass? But if you keep thinking along these lines, here you are absolutely... You can't solve it this way, right? There's no way you can solve it with absolute certainty. So we probably still need to look for a pattern. In other words, to find a general formula or a summary expression. So should we try to summarize it? Only then can we analyze, for example, after the 6th pass, whose feet the ball is at. And usually, here, when the ball is in someone's hands, there are a few possibilities. Either it's in player A's hands or player B's or player C's, right? Let's consider this. After the nth time. Following the completion of the nth turn, we consider the specific event in which the ball is in player A's hands, and we shall formally denote this particular event as AN. So we'll call this event AN. All right. Then our BN refers to the ball being with player B. And then CN should be the event where the ball is with player C. All right, so at the nth time, since it's all about equal probability, the probability that the ball is in A's hands, in B's hands, or in C's hands, these 3 probabilities added together must equal what? The sum of the probabilities of these 3 events happening must be 1, so first we can definitely write PAN plus our PBN. Plus PCN equals what? Equals 1. Now let's think about it. Since we're mainly focusing on player A, because the starting point given is player A, let's consider D. We've said that dn plus 1 is related to dn, meaning the outcome of the next round only depends on the current round, right? The outcome this time is only influenced by the previous round. So it's clear that our PAN plus 1 is also dn plus 1. How does the probability of it ending up in player A's hand get affected? If on the nth round, if we're looking for the probability that it's in player C's hand, then there's a 1/2 chance of what? Passing it to player A. So it's 1/2 times PBN. Right? Also, if on the nth round the ball is in player C's or player B's hand, then when dn increases by 1, there's a 1/2 chance it gets passed to our C, passed to our A. If on the nth round it's in our C's hand, then similarly there's also a 1/2 chance it gets passed to our what? Passed to our. So in this way we can write the following equation: PAN plus 1 equals 1/2 times PBN plus 1/2 times what? PCN. Okay, these are the 2 equations we get regarding this. With these 2 equations, we can transform them because we can clearly see that there is a definite quantitative relationship between PAN, PBN, and PCN. PAN equals what? 1 minus PBN minus PCN, right? So PAN plus 1 should equal what? It equals 1/2 times 1 minus PN. Originally, what was it? It was to explore and explain the relationship among the 3 events A, B, N, A, B, C. But now what have we done? We've transformed it into a relationship involving the same event, making the connection between the nth time and the n plus 1th time very clear. Now, what do we need to do next? As long as we can transform it into a geometric sequence, won't this problem be solved? Now, this is the ultimate goal for most Markov chain problems, right? To turn it into a sequence problem, isn't it? So how should we construct this sequence problem? Let's expand it a bit first. Expanding it, we get something like p times a sub n plus 1 equals something, which is equal to 1/2 minus 1/2 times p times a sub n. For this type of problem, if you want to make a transformation, most likely it will be a geometric sequence. If it's a geometric sequence, then what does that involve? We need to look at what parameters are next to these events, and on our right side, the parameter next to this event is minus 1/2. So here I'll teach you a method. Introduce a parameter value and construct it like this. That is, p times a sub n plus 1 minus x equals 2 equals minus 1/2 times p times a sub n. How about it? Subtracting x again. What's the point of doing this? It's exactly what? You could say it's a one-to-one correspondence in our arrangement, right? Or you could say it's secondary, right? The arrangement is a one-to-one correspondence, so how should we solve for this x? Notice that there's only one parameter, 1/2, and 1/2 should equal the sum of the terms on both sides. Move this term over, and 1/2 should equal x plus what? Plus. The value of x is just x plus 1/2 of x, which naturally results in a total of 3/2 x. So then what should our value for x be equal to? Our x should be 2/3, or perhaps it is 1/3. So our pan added to 1, subtracted by 1/3, is exactly equal to negative 1/2, multiplied by the quantity of pan minus 1/3. Right, so from this we can see. So our pan, this equation, pan minus 1/3, is a geometric sequence, and the common ratio is negative 1/2 is the first term, right? Let's pay attention to the first term, which is a11 when n equals 1, the first term. It's PA 1 minus 1/3, and let's note that the ball was initially in player A's hand, so is this counted as the first time? No, it's actually the 0th time, because only after it's passed out do we start counting the first, second, and so on, right? So the first pass is from player A. So does the first receiver include A? No, it doesn't. In other words, the probability that the ball lands in A's hand on the first pass should be what? It's 0, right? So the first term should be what? It should be 0 minus 1/3, which equals negative 1/3. So it should be a geometric sequence with the first term negative 1/3 and common ratio negative 1/2. So what we have is pan minus 1/3 equals negative 1/3 multiplied by a minus 1/2 to the power of n minus 1. Consequently, if we examine very carefully at our pan, we can see it is a structured sequence, and we can effectively summarize its distinct and recurring mathematical pattern. It should be, when expressed in its full form, precisely and consistently 1/3 minus 1/3, multiplied by negative 1/2 to the power of n minus 1 squared. But what we ultimately need to find is the probability of the ball landing in B's hand, the probability of the ball being in B's hand. Now, if we want to find the probability of the ball being in B's hand and in C's hand, since the first time the ball is thrown out from A's hand, then on the nth throw, the probability of it landing in B's hand or in C's hand, its probability should be equally likely, right? Equally likely because it's obvious that the two of them are symmetric. Only A is special, since the ball is thrown out from A's hand. But as for B and C, there's nothing between them that affects the outcome, right? So we know that our PBN is equal to PCN, which should be equal to 1/2 times 1 minus PAN. So that's equal to 1/2 times 1 minus 1/3 plus 1/3 times negative 1/2 to the power of n minus 1. And here we don't need to make it too simple. So let's just set n equal to 60. Our value for PB60 should be exactly equal to 1 divided by 2 times, and then in parentheses this is 2/3, and then right here we subtract our the number 32. 1/3 times 32 is 1/96 equals. So 1/3 minus 1 over 192 equals, what is this? 64 minus 1 is 63, divided by 3 should be 21 over 64, so 21/64. Which answer do we choose? The answer is C. That's the solution to this problem. You can pause here and carefully go through the logic. If you have any thoughts or questions about this problem, feel free to leave a comment or send a private message for friendly discussion. If you're interested in this series, please like, follow, and save it, and feel free to share it with friends who might find it helpful. Let's all get stronger together every day. That's all for today. Bye for now. 100.